Hello everyone, thank you for being here. My name is Geanina Sitar, and together with my colleagues, we've developed a study titled Educators' Perspective on Insect Conservation, Resources and Challenges in Environmental Education in Romania. Today, I'd like to share with you some insights into how Romanian teachers perceived insect conservation, what helps them teach about it, what holds them back, and how and why this topic matters more than we often realize. Before presenting the results of the study, I like to offer a brief overview of my academic journey that led to this research. I graduated from the Faculty of Biology and Geology at Babes-Bolyai University, where I earned both my bachelor's degree in biology and a master's degree in ecology. During those years, my research focused on butterflies and moths. After completing my master's degree, I made the decision to pursue a PhD in sciences education, driven by a strong conviction that in Romania there is a real and pressing need, a lack of researchers actively involved in environmental education. Also, uh, there is a need to more accessible teaching resources and stronger connection between biology and practical environmental education. While my work with butterflies continues, I now feel a deeper responsibility to raise awareness and help bridge the gap between science, education, and society. Now, let me ask you something. Have you ever truly wondered why insects matter, or why we depend on them more than we might think? Let me put it into perspective. Around 70% of all known species on Earth are insects. That's an overwhelming majority. These incredible creatures live in almost every habitat, from forests and fields to rivers and even cities, and sometimes also in our homes. And they provide us with essential services like pollination, decomposition, and even pest control. And yet, despite how vital they are, insects are often overlooked. Studies show that many people have negative feelings towards them, feelings shaped by cultural beliefs, lack of information, or even a single bad encounter. But here's the good news. Education has the power to change that. When we teach children and adults about the importance of insects, we shape more than knowledge. We shape empathy, responsibility, and curiosity. That's why we need effective, engaging educational programs that reconnect people, especially young people, with the natural world, starting with the smallest and most misunderstood creatures. And if you're still not convinced about just how crucial insects are, well, let me share a powerful example. As I mentioned before, pollination is one of the main contributions of insects. Approximately 75% of our crops depend on insect pollination. However, have we ever considered the consequences if these valuable pollinators were to disappear? Allow me to share a well-known case from some part of China, where pollution has caused a drastic decline in insect populations. As a result, apple trees in this region ceased to bear fruit. The local community had to be directly involved in manual pollination using a tool similar to the one presented in the slide. Tragically, this decline in insects is not limited to China alone. It is a global issue affecting our entire planet. If we fail to take the necessary measures, we may find ourselves compelled to design our own artificial pollination tools. When Romania joined the European Union, it also made an important commitment to integrate environmental education into the national school curriculum. Among the key topics highlighted in this effort are biodiversity loss, including the alarming decline of insects and the urgent need for their conservation. Now, if we ask ourselves who might teach about insects in the classroom, the answer seems obvious: biology teachers and primary school educators, especially during science lessons. But behind policies and good intentions, we must confront a deeper, more pressing question. Are teachers truly prepared? Do they have the tools, the knowledge, and the support they need to teach this topic effectively? Or they are facing real challenges, a lack of professional training, missing materials, and insufficient institutional backing. While strategies can be written easily, real progress depends on understanding whether teachers feel supported and how we can help them in ways that empower rather than overwhelm them. The study explores exactly that. Teachers' perceptions, attitudes, readiness, and needs related to teaching about insects and their conservation. The data collection took place between November 2024 and January 2025. We designed a questionnaire consisting of 28 carefully crafted questions, and to ensure its quality, it was validated by experts in biology, psychology, and education sciences. The survey was distributed online through Google Forms, allowing us to reach a wide and diverse group of teachers. Participation was completely volunteer and anonymous, ensuring that respondents could share their views openly and without pressure. For the analysis, we used Python to run the statistical processing. In total, we received 239 responses to the questionnaire. Out of these, 178 were submitted by teachers, the target group of our research. Among them, 119 were biology teachers and 59 were primary school educators. Most of these teachers grew up in rural areas and have over 20 years of teaching experience. One of the survey questions focused on academic background, as expected, given the higher number of biology teachers in the sample. This was clearly reflected in their qualifications. Over 100 respondents had degrees in biology or biochemistry. The next most represented group came from the field of education sciences, which aligns with the primary school teachers. To begin the results section, I like to present an analysis of teachers' attitudes toward insects and their level of comfort, as shown in the figures on the left side of the slide. Overall, biology teachers reported more positive attitudes and greater comfort when interacting with insects, while primary teachers tended to show more neutral responses. Regression analysis revealed that two factors significantly influenced these attitudes: the frequency of direct interaction with insects and the level of general knowledge about them. Interestingly, the childhood environment had no significant effect. That challenged the common belief that early exposure to nature leads to more favorable views of insects. This finding suggests that hands-on experience and current experiences with insects play a much more critical role. Such direct interaction not only enhance environmental learning for students, but also help teachers develop more positive and open attitudes towards biodiversity. This part of the analysis examined teachers' professional training and their knowledge about insects. As expected, biology teachers reported more structured training and scored higher in general, specific, and pedagogical knowledge. However, about 3% of them had received no insect-related training at all, pointing to possible gaps in the higher education. In contrast, primary school teachers mostly had minimal exposure to entomology during training. Still, those with over 20 years of experience performed better, especially in general and teaching related knowledge, suggesting that practical experience can partially compensate for limited formal education. A heat map confirmed that the highest levels of knowledge were found amongst two groups: biology teachers with strong academic backgrounds and primary teachers with extensive experience. Overall, the finding highlights the need for solid initial training to ensure teachers are well prepared to integrate insect related topics into environmental education. Next, we'll present the perceived barriers reported by educators regarding the integration of insect-related topics into school-based environmental education. The data show that the two biggest obstacles are a lack of knowledge about insects and difficulty in keeping students interested in the topic. These results suggest that many teachers feel they need more training in this field and better teaching methods that can help them present scientific topics. Other barriers, such as not having enough time in the curriculum or not having the right teaching resources, receive lower average scores. Still, they remain important because average values above 2 show that many teachers see them as real challenges. So, the conclusion is clear. It's not just about teachers' willingness to teach this topic, they also need proper support through training materials and a clear place in the curriculum. On the right side of the slide, we can see the results from a logistic regression model. This analysis helps us understand what factors actually increase the chances that a teacher will include insect-related content in his or her teaching. We found that the following factors are strong predictors of teaching behavior: level of education, general and specific knowledge about insects, years of experience, and how many barriers the teacher perceived. In short, the more prepared and experienced teachers are, the more likely they are to teach about insects. One interesting finding is that attitudes towards insects, even when positive, does not influence whether a teacher actually teaches about them. This means that liking insects is not enough. Teachers need to feel confident in their knowledge and they need the tools and the resources to support their lessons. This conclusion is also supported by other recent studies, although it differs from older research, which argued that a negative attitude lowers the chances of teaching about environmental topics. In our case, knowledge and support matter more than attitude. So, if we want insect related content to become part of real classroom practice, we need to invest not only in changing how teachers feel, but also in training, pedagogy, and institutional support. Next, we looked at how teachers approach insect-related topics in schools, focusing on resources, goals, and activities. Both primary and biology teachers valued visual materials and study kits, though primary teachers relied on them more for engaging young learners. Biology teachers preferred collaboration with specialists, reflecting a more scientific and interdisciplinary focus. There was broad agreement on the importance of teaching biodiversity and insect ecological roles. Primary teachers also emphasized shaping by a positive attitudes towards insects, highlighting their focus on emotional learning. In terms of activities, biology teachers favored field work, while primary educators preferred hands-on projects like insect gardens, more accessible and suited to younger students. Overall, each group brings unique strengths. A combined approach, blending scientific depth with creativity and emotional connection, can make insect education more effective and inclusive. So, this research is not just about insects. It's about how we teach, what we value in education, and how we connect science with everyday life. By understanding the challenges and opportunities that educators face, we take one step closer to building a more informed, curious, and environmental responsible generation. I hope these findings will contribute to a broader conversation about environmental education and inspire future initiatives that bring science closer to the classroom and the classroom closer to the nature. Here presented some of the main sources that informed my work, and thank you for your attention.